Permutations is a grouping of outcomes in which the order does matter. This can be illustrated by using listing method, using a tree diagram, using a tabular method, or the fundamental counting principle, or the FCP. This is the formula used in solving a permutation problem, wherein it is read as the permutation of n taken r at a time is equal to n factorial over quantity n minus r factorial, wherein n here represents the total number of objects and r represents the number of objects selected. So this exclamation point here is read as factorial. In solving for the number of permutation, it involves evaluating the factorial of a number. So this is the factorial notation, and it is read as n factorial. And this is the representation. So n factorial, that is equal to n times quantity n minus 1 times n minus 2 times 3 times 2 up to 1. So example, if you are asked to evaluate 5 factorial, so this is the expanded form of this factorial notation. 5 times 4 times 3 times 2 times 1. If we're going to multiply them, that is 120. So the value of 5 factorial is 120. 3 factorial, if we're going to expand it, it is 3 times 2 times 1, and its value is 6. 0 factorial is 1. So let us apply this formula in this given situation. 6 people are in a contest. How many ways can first and second place be awarded? So in our given, since first place and second place cannot be interchanged, let's say our first place is Zaire and our second place is Christian. If the first place is Christian and the second place is Zaire, so that's another situation. Therefore, the order here is important. So it means this given problem is under permutation. So we're going to use the permutation formula, and we're going to identify our n in this case. Since the n here is the total number of objects or people, so there are 6 and 2 taken at a time, first and second. So therefore, our r is 2. We're going to put it in our formula, then simplify. So 6 minus 2 is 4 factorials, expand them. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 4 factorials is 4 times 3 times 2 times 1. Then multiply them, or for us to save time, we can cancel this and multiply the remaining consecutive numbers of 5 times 6 is 30. Therefore, there are 6 ways that 6 people in a contest to be awarded with first place and second place. In our given number 2, how many ways can a president, a secretary, a treasurer, an auditor of grade 10 Maxwell class be elected among 19 students? So since each officer here, they are unique, so therefore the order is important. So we will be using the same permutation formula and identify the n. Since there are 19 students in all, so our n is 19. And our r is 4 because there are 4 officers taken at a time: president, secretary, treasurer, and an auditor. So there are 4 officers. So we're going to put it in our formula, then simplify. So 19 minus 4 is 15 factorials, then expand. So 19 times 18 times 17 times 16 times 15 factorial. So we stop at 15 factorial because the denominator is also 15 factorial. So we can also do this way to save time and space. Then we're going to multiply the remaining numbers. So 16 times 17 times 18 times 19, this gives us 93,024. So it means there are 93,024 ways for us to elect 4 different officers in grade 10 Maxwell with 19 students. In given number 3, how many ways can the letter A, B, and C be arranged? So since ABC is different from BAC, so again in this case, the order matters. So therefore, it is under permutation problem. So our n here is 3 because there are 3 letters given and 3 taken at a time. So our r is also 3. So we're going to substitute it in our formula. So in here, 3 factorials. So 3 minus 3 is 0. That is 0 factorials. Then expand 3 times 2 times 1. That is 6 divided by 1, 6. Therefore, that is the permutation of this given.